To give a little bit of background, I'm mechanical engineer by heart. What I mean that is like I did my undergraduate in mechanical engineering. I was working with Larsen and Toubro for a couple of years as a business analyst, like trying to crunch the data there. Then kind of like pursued more into the data science piece. But it's always it's a happy home away from home kind of feel with when I always discuss about manufacturing. And yeah, here we are, happy to like take this opportunity to discuss more about manufacturing and with H2O.ai and the products which we kind of like have in focus, and more of like what could be, where the market is nudging towards. So those sort of discussions would be our context for today, and definitely like the predictive maintenance. So consider would be one of, I've got one use case where we could kind of like go over, and definitely there is also like CV computer vision image inspection, which is also like through driverless AI, which we could kind of like go over. The demo would be the context for today's discussion. um, and like yeah, to give a little bit of background about H2O, like make your company an AI company is our motto. And so it's an open source leader, if you kind of like think about it as um, so if you kind of think about it with respect to like the open source projects like H2O3, sparkling water, even one of my one of the very interesting project which I could say is the data table, where well before joining H2O, when I was like working more towards our the extra nudge of like handling bigger data sets was always helpful with data table. I didn't know that H2O was kind of like sponsoring and making that as an open source project, but after kind of like joining H2O, that is where I kind of came to know. And authors like Matt Dowell, who works with me in H2O, it's always a pride to see kind of like when you kind of like see things in that way, where he had utilized data table and awestruck with respect to it, and when you meet them in person, meet the author in person. So and definitely like right from H2O3, where if you kind of like see H2O's lineage, you could always like see like algorithm as well, like or even like deploying it, making life easier, even through the enterprise AI level, or even as an individual person, where like pushing things into production. At the end of the day, through Mojo, or even through explainable machine learning concepts, which we will kind of like go through. So those are like the efforts and achievements as done by H2O at the end of the day. And yeah, it's kind of like still a lot to go on, would be my take. And to give a little bit of background, so consider we are a like team of 220 people, and like close to 15ish, 16ish, maybe I need to get back to Sauraam about the number, but 10+% of the Kaggle grandmasters do work with H2O right now, and they are kind of like devoting their time with their expertise which they gain through the competitions, and kind of like bring it back to the product, and bring back to the like consider like even through the open source discussions as well. So that is one of the takes. And yeah, we have presence in Mountain View. That's our headquarters, and like in India as well, in Chennai, where I'm kind of like residing right now and discussing with you. So like definitely like consider more than me explaining H2O, you would have already known, and because of your tryouts with respect to the open source machine learning projects like H2O3 projects and such. And in every industry, like getting we would be getting into the manufacturing, like one of the examples, which is the Stanley and Black and Decker, which we had got. Definitely we would kind of like go through that. And but generically speaking, it's a machine learning platform, so we would be kind of like having different verticals, right from insurance, right from financial sectors, healthcare, case of permanente, and retail. We kind of like have our presence there through helping them, supporting them through their model deployment, through the machine learning. Like, so consider driverless AI is one of our flagship product. Hope we could kind of like we would kind of like have a demo on that one, where it automates right from feature engineering, automatic feature engineering, then model deployment on operations, and it could also like handle NLP kind of problems, or even image. And it is definitely like it is state of the art. Like there is always an NVIDIA GPU acceleration which is available. So all sort of like the newbies, like the state of of the art, whatever you are trying to like deploy, we kind of like already have that as a package for you for the enterprise discussions. And definitely on the open source, like where consider like some of our customers are kind of like still hailing through and utilizing our open source H2O3 projects, which we would kind of like see as well. So these are like our domains. And getting back to the manufacturing, so consider the manufacturing, how it could leverage AI. So these would be where we had seen with Stanley Black and Decker, Petronas, Mitsubishi, even with Cisco. So it would be like through these kind of like problem statements specific to manufacturing. So right from the supply chain, where it would be starting with the stock level predictions, or even with respect to the demand forecasting, or like the returns forecasting with respect to the supply chain. And predictive maintenance is one of the good use case for AI to like where AI could be leveraged and like make the better of it. Look into the like the predict the mission failure. I've got an example data set which will kind of go through that one. Preemptive maintenance for sure, and the fault detection as well. Like whether is what is the probability of this failure, and if this failure is because of the component one failure or the component two failure, kind of insights which we could derive at the end of the day using our platform. That would be our core discussion for today. And like which is like these would be the top two one. And definitely like consider freight and shipping again, like the same dispatch failures, more of a like the damage packages prediction. And with respect to the time and the location, the travel information, we could also like have a probability of like that a probability of like how much the damage that would be. And back to the IT optimization. So consider even with respect to the vendor management, master data management kind of technique, where like companies are trying to master data management had been there for the last 15ish 20 years of problem statement. But now we are in the position of like throwing a good amount of computing power and utilizing AI for answering those sort of questions. So those would be the focus of like to start with respect to the manufacturing, where we had seen specifically, at least I could talk about with these with our customers here. And and deploying. So consider, okay, we found a problem statement to try, and we found like a good amount of data where we could kind of like leverage. And where H2O AI kind of like platforms would be totally helpful is definitely like consider with respect to the deployment. So where normally with respect to each of the problem statement, if it is gonna like 6 months 8 months in the usual fashion, where I had seen even when I was kind of like working in the manufacturing domain back in Medtronic, or even with Dexcom, which was more on the healthcare manufacturing, we were kind of spending a good amount of time with respect to the deployment. But right now, with in 2020, I think you would be in a position, or like you should be in a position to like leverage these kind of platforms. Why is like consider like those 6 months of effort with respect to the feature engineering and the model deployment and the evaluation perspective. It kind of like cuts down to like maybe 2 days 3 days, just like extensively looking at it in terms of like what would be the top feature where the model could kind of like predict. Even within 2 hours you would get a good model. But to gain the trust, that is where consider even now the product isn't the lack is not with respect to the product, it is us trying to build the trust. So that is where the most of the time with respect to, even if I kind of like go 2 to 3 days would be there. And definitely like over the period of time, like you could see data science is like, yeah, it's always a team sport. And like the lack of AI talent with respect to getting a good model at the end of the day, doing a good feature engineering. So those sort of like strategies where these, or even consider we had seen a good amount of like use cases where driverless AI would be in a position to like bring one of the good feature engineered features for you to review, where it wouldn't have been feasible if you had done that manually. So those are of so at the end of the day, what do we see is like you would be in a position to attack a lot of other use cases and get the best out of it. with respect to your time. So that would be the end takeaway, because at the end of the day, we are kind of like answering the business and time. So this is where definitely like looking at the AutoML platforms like driverless AI would be totally helpful. And definitely like which is the time as well, which is like it takes months now. It takes us to have a like deployable model in Java, Python, R, and C++ or whatnot. Even if you have to like deploy that in Spark, that would be totally feasible, where we kind of like have our package, like have our you could kind of like take the feature engineered plus the final model in either of these tools, where you could utilize and deploy it at the end of the day. And this is with respect to the deployment. This is with respect to the time. How do we gain trust is where explainable AI would be totally helpful. So consider explainable AI like H2O like platform, where Shapley values or K-Lime kind of information at the end of the day would be totally helpful for the business user or the end user to like evaluate and gain trust to the model would be the take. And so yeah, again, like I kind of like talked about the problem. How are we kind of like answering it is like the expert data scientist at H2.ai, thanks to Kaggle grandmasters, where I kind of like I could kind of like envision how they think, and like it's always fun to like learn from them, and working with them, like they are in the position to like help us in building these kind of models. And months to ask, definitely like consider time to insight. It kind of like with the GPU acceleration, like definitely like NLP or the computer vision, which I've got an example which we'll kind of like go through, and we would be like within hours we would be having a good deployable model. And explainability and transparency is always, that's always kind of like needed. We had got Autodoc, that's one of a good feature. Auto visualization again, where like a grammar of graphics author, Dr. Leland Wilkinson, who spends a good amount of time in like yeah, making it better. And like we had got good amount of like techniques there. We could also like use that for the auto visualization. Just if you can like throw the data, it would be in a position to like sort out the best visualizations for you to like look in. And definitely like machine learning interpretability, it's one of the hot topics, right? Like even like how do we kind of like interpret the final model? Do we see the bias in the data? Do we see the bias in the model? How do we how are we gonna answer it? Those sort of like techniques would always be there under the MLI umbrella. And yeah, definitely like consider to try out driverless AI. There's a 21-day free trial. You don't even have to like ping anyone. You would be in a position to just download it from our website and try it out, which I'll kind of like showcase it right now. And it's at least with respect to your projects, where you kind of like have an on-prem machine, it is worth to try and see how the model is kind of like picking it up, or what would be. And definitely I think it would be on par with respect to your results, or even sometimes better than that. Most of the times it has been better than that with respect to the all the tryouts, the analytics which we had done before, because of where it could kind of like do good amount of feature engineering and take the best model for it to consider and like predict. So let's, before we kind of like get into again kind of like let's go into the demo. But more or less, this is what I want to like highlight in the nutshell with respect to the manufacturing. So a couple of ways where AI is getting leveraged. One is like reduce running cost. That is one good takeaway. And the next one is like what would be the opportunity to maximize yield. So those, in with respect to those techniques, like whatever we had discussed, consider like the supply chain problem, where it would be more of like running cost reduction would be its motive. Whereas with respect to the maximized yield, it would always be predictive maintenance is a very good example, where we are kind of like making the best use of our downtime, so that we don't have a good amount of downtime, would be the motivation at the end of the day. So, and we'll get into the supply chain use case, but let me start the demo. One minute. Okay. Okay. This is one good data set which I had got. I think it's from the open source, maybe Kaggle or UCA machine learning repository. So this data set, and at the end of the day, so consider I'd got mission ID information, and I want to like predict with respect to the time. whether like would it be for the next 2 hours or 3 hours. The prediction is it kind of like goes in that way, whether I'm gonna like have a failure with respect to the component 1, component 2, and whatnot. So consider on average with 4 hours window, you could kind of like see I'm always like having an RF window. Yes, RF window with respect to this particular data set. I'm kind of like populating the like in the voltage mean for that particular R, and how it had been kind of like the standard deviation of it for the last 24 hours. What was the pressure? Kind of like what was the voltage which it kind of like pulled, and how is the vibration with respect to it. So those sort of like just a little bit of metadata of that particular like machine, and I'm kind of like populating it, and I'm gonna like use that for the prediction whether it kind of like got failed or not. And if it is kind of so, to envision this data set, this it needs a little bit of data preparation, because the logs, how do we kind of like convert it into a supervised learning problem? It is always, and how do we envision it? So consider like each of the rows should be kind of like consider it as an IID, which is like should I consider that as time series problem, or should I kind of like go with the usual classification? So those sort of decisions has to be made. But at least with respect to this data set, where I'm kind of like having a very huge imbalance of like the component 1 failure is like 1%, and the rest of the stuff is kind of like there is a little bit of tail there, and 98% it is always like on with respect to it, it's working fine. So even with respect to this data set, driverless AI would be in a position to like uh, build a model and get the better predictions out of it. At the end of the day, we would see the result. And I hope I'm making myself kind of like clear with respect to what this data set stands for. So this is like a good predictive maintenance data set, where you would also like find it in a UCI machine learning repository, and like to take it forward. So consider you kind of like in driverless AI, the first step is like if you kind of like click into the predict, um, and we want to like predict failure, and the failure is having like five unique information, which is like the component 1, component 2, component 3, and component 4. And the most frequent is the none, which is like no failure with respect to that particular time. I'm not considering it as a time, but with respect to, because I had got a chance to like populate the information for the last 24 hours for this particular hour, how well the voltage, the pressure, and the vibration is kind of like the machine is receiving, and which component is gonna fail. So that is how I had populated the data. But the same problem actually, like I'm even one of the triads which had got, at least not in this instance, where we could also like consider the same one as a time series classification problem. So it's pretty much there. So where how do we envision the same like time as a predictive maintenance, as a time series, or as a classification? That kind of like depends upon us. But usually, or every problem kind of like goes with the time series classification problem. But I want to like use it as, I want to like showcase this kind of technique where you could kind of like populate it and taking it forward. So definitely like consider driverless AI. What would it do on top of it? Like it would be in a position to like use on the left, you could kind of like see these would be the like some of the feature engineering it's going to do with respect to this particular setting, which is like numerical to categorical target encoding. Target encoding is a very good technique in like squeezing the best out of the models, and definitely the cluster distance, cluster target encoding. So those sort of techniques it's going to try. And even if necessary, we can kind of like there is a open source repository which we had got. If you need to kind of like have your own transformers, you could also like bring it in here. And as this one doesn't have any images, it is not going to try out, though you kind of like see here marked yes, but it doesn't see any textual information, so that is why it is not kind of like popping up. So those sort of like techniques. So if you kind of like go ahead and launch the experiment, it's gonna predict with respect to this particular time what would be the failure of the what model is going to fail, what component is going to fail, would be the target. So I got a chance to like at least run this before, and let's use that guinea pig it for the discussion purposes. So at the end of the day, so consider like once you kind of like launch the experiment, it would be in a position to like yeah, this would be the final result. And you could see the top variable importance is like the cluster target encoding for and it had done a complex, like a complex feature as well. That is where machine learning interpretability would be helpful. So consider what it had done is like it had grouped with respect to the error count for the last 1 hour, rotation mean for the last 24 hours, the vibration mean for the last 24 hours, and it had kind of like created into 50 clusters, and it is using it as one of the column, one of the feature, engineered features, and it is using it for the prediction. This is whereas consider the fourth one, which is the error count. It's a straight up original column, which is like the last, how much is the the error logs which we had seen over the period of time, kind of information boiled up, and the voltage mean for the last 24 hours. That's one of the third feature. Again, it's original, but you could see a mix of the original and the engineered features is kind of like helping the model to get the best out of it. So each of the dots is like one particular model. The first one is the XGBoost with 35 features, and you could kind of like see it is kind of like having a log loss of decimal 0.1, and at the end of the day, the final model is kind of like having dot 0.0008 as a feature, like as a log loss information on the validation, like on the validation side. So that is what consider like the same, the predictive maintenance at the end of the day, where we could kind of like see that where we could kind of like use this in the model into prediction, where we could kind of like look for this particular R, we could kind of like boil up these sort of information with respect to what was the voltage mean for the last 24 hours, error one count, and it would be in a position to predict whether it's gonna, which component is gonna fail at the end of the day. You could see this is the confusion matrix, and the component 1, component 2, component 3, and component 4. This is none, which is kind of like this is the top one, where it kind of like calls for where it is whether the failure is with respect to the component 1, 2, 3, or 4, and or it's not going to fail at any point, would be our prediction at the end of the day. It would be totally helpful for us to like look this would, I'm kind of like boiling up for an hour information, but we could also like use it for the next 6 hours, whether it's gonna fail kind of model, and it keeps on running in production and gives the alert whether like if there is any red flags with respect to it. So that is one way of like consider. This is one of the good ways of like attacking the predictive maintenance problem statement, which we had got with the right data in place. And definitely like a little bit of massaging on the data is always needed, and that is where a data recipe, I hope, I mean, like there are good amount of discussions with respect to the data recipes available for you to kind of like go through, where you could also like do that in the driverless AI. Yeah, if not, we would always be there, get into the one-on-one discussion with respect to that, how you could massage the data. And this model, I mean, I'll kind of like showcase it quicker, where like the final model, whatever we had built, how is that kind of like performing at the end of the day. What does it mean is like consider what is the topmost feature for us to consider, the error one count, though it wasn't in the top. This is like the fourth feature, fourth variable important feature, I think, but the Shapley, it is one of the top features, because you are kind of like looking at the naive Shapley, which is the version like rather than looking at the transform feature, we are kind of like taking the same Shapley information and looking at it with respect to the with respect to each of the like the original features which we had given as an input. This is on the global perspective, but consider we want to like analyze. This is, I'm kind of like pulling it from the train data, but you could also like do the same with respect to the test data. And so where this would be in a position to consider. Okay, let's do row number. Okay, so this would be kind of like giving the local interpretation as well as like a local interpretation as such. So consider this particular mission ID, how well what would be the though the final model, like the global importance is with respect to the error one count, it could be because this one is kind of like marked as a failure is because of the volt mean 24 hours, where like though it is a second feature for that particular prediction, it is on the first one. So those sort of takeaways on the global interpretation as well as the local interpretation is feasible through a driverless AI, like machine learning interpretability module. So getting back to the problem, so consider like that is what one thing which I want to like showcase. And getting back to some of the use cases which we had got is like this is a usual supply chain optimization, but you could envision it as demand forecasting, or like consider like yeah you could kind of like envision as a demand forecasting piece, where we would be in a position to like use that demand to like stabilize our like the manufacturing line. So that would be with respect to the industrial product line would also be kind of like feasible. That is one of the good use cases, more or less, where you could also like look at the time series forecasting piece which we had got there in driverless AI. And again, like with respect to the like you would be kind of like looking at it with respect how fast, how quicker we would be in a like in a position to like have one of the best models to deploy. And did we kind of like get that gain trust with respect to these models. That is where these like platforms would be totally helpful in like giving a time savings, as well as like giving an accurate prediction with respect to the problem statement which we had got. And so the one thing which we kind of like discussed, again, like giving a little bit of recap, which is like the predictive maintenance on the driverless AI, how catch the problems before they occur. So as we kind of like showcase, so where we would be in a position to like predict for the next 1 hour whether it is gonna like the machine is gonna like have any component failures or not. We could also like extend it for 4 hours and 6 hours, how the model is kind of like performing. The one which we had got right now is kind of like having a very good prediction, but even with having a imbalance of like 98 versus 1, and the tail kind of goes on where 98% of the time the machine is on with respect to that particular data. And if it had got failed till it is kind of like up and running, we wouldn't be having the logs. So those sort of like again the data cleaning which we have to do. But yeah, it's either or that's pretty much that's we have to like a little bit of clean the data there. But yeah, not a necessary it depends on the data again. Yeah, consider like we had seen where even with respect to the logs, kind of like kept marking it as failure because the downtime was pretty like minimal. It's still the model was performing better. So those sort of like whether the cleaning would kind of like improve the model, improve the prediction, and gain trust more in the AI model. That sort of like it kind of like deviates towards that. And I think any like logical decision there, it makes sense based on the data and based on the problem statement which we have got. And like predictive maintenance, definitely it's one of the rising need. So consider because a good amount of like uncertainty I mean like that is where AI is like always there to help us out with respect to where these focused problem statements like the predictive maintenance and the uptime and downtime, where we could kind of like have a better hold of it. So those sort of like this is a very good if we are kind of like looking into the manufacturing, where you're primarily focused on the data collection piece. The next step which you have to, if you want to like have a little bit of go there, then I would definitely start looking into the predictive maintenance piece would be my recommendation, where you would be kind of like you with the which is a low hanging fruit, because you would be having a good amount of logs. Definitely like consider even if it is a numerically controlled machine, NC machines, we have a good amount of, I mean I could see a good amount of logs hailing from a little bit of mechanical background, where I'd seen got a chance to like look into the logs as well back in the days. So definitely like those logs would definitely be there. And this a little bit of low hanging fruit which I want to like emphasize, so that you could kind of like start your AI journey once the data collection piece, so a little bit where you are kind of like comfortable there. And this is again like this is one of our European manufacturer, like where we were kind of like have a good amount of like savings at the end of the day with a predictive maintenance use case. And like not to make it more complex, the more the data better, it's always there. And but at least like the usage of sensors with respect to the predictive maintenance. And like the one of the implementations which they had got is like where as a first step towards predictive maintenance, the company installed air pressure system sensors, which is kind of like the data capturing piece. As I said before, like if you are kind of like comfortable with respect to the logs, the data which you could kind of like store, which you are storing it right now, then definitely it's a good good to go. But it's again, it's a little iterative process. So consider you had got the data, then how well it is helping us with respect to the model prediction. Then again, the back to the cycle would be like, can we capture more data to make the model better, so and gain confidence in the model, would be the cyclic try, or like with respect to each of the use cases. That's how we improve. So they definitely start with the data, whatever we kind of like have, because how well it would add value, you would also like you could quantitatively evaluate at the end of the day whether the additional data would it be helpful or not. And so again, like this is where consider the data procurement, where if the data is already available, yes, that's good to go, where you can start with the data preparation and the feature engineering, model training, predictions, and deployment. It's already been taken care of by driverless AI. The first two steps, if you're kind of like comfortable and you could kind of envision it, the rest of the step, it takes a very quicker amount of time for us to like deploy. And the other use case which I want to like emphasize as well is like with respect to the human inspection as well, like where I had seen even in the past, where I had seen like the little bit of evaluation, the automated inspection, like computer vision inspection, would always be helpful. That is where again driverless AI would be helpful, which I want to like the same problem taking into the driverless AI. Like again, I'll kind of like showcase that back. So one of the problems which I want to like emphasize is like this is more on the computer vision. So computer vision as such, so consider, so I'd got the pictures of the casting, whether it is kind of like okay or defective. I'd got two information, like this is okay front is like they had kind of like this is again one of the Kaggle data sets available for you to try it out, and for at least like to see how the imbalances are and such. And so with respect to this, I'm kind of like guinea pigging on that data set, but we had kind of like seen good amount of examples, cases where computer vision would be totally helpful in supporting the human inspection, which is kind of like happening throughout. So even to give you an example, I had been there with Medtronic, Tempe campus, and with respect to that particular use case, we had got a human inspection, but we did kind of like deploy a couple of computer vision models to support their decision at the end of the day. One thing is like not definitely like not removing human loop out of this decision making processes. Like that's always a FTA, like the compliance perspective is always kind of like comes into play. But the other one is like definitely like it was making the whole like decision faster, better, and they could also like trust the computer vision piece. And at the end of the day, it helps us to improve the quality. So so that is where consider like where we had kind of like seen that particular use case. And back to this use case where we are kind of like gonna like use again driverless AI to evaluate the casting, which is like we kind of like have um, two particular classes, which is the defective front and the okay front. I think the okay front, I think this is from the Indian region data set, just looking at the classes. And those are the two classes which we had got, and we had got good amount of images which we kind of like saw there, which is like whether it is kind of like the defects are kind of like okay or not. So that's our data set, and you can kind of like go ahead and kind of like do a prediction straight up, and it would be in a position to just mark image and label. You can kind of like mark it as label. Yeah, the okay front and defective front is our two particular examples. And without thinking further much, consider in driverless AI, I mean like there is a Kaggle grandmaster recipe which I want to like emphasize, which is like you can kind of like go ahead and select image model. And image model, what it would definitely do is like it would be in a position to like use exception ResNet 32 ResNet models. And let me kind of like the default. Yeah, so these are like, exception, like, ResNet 34, ResNet 50, Inception v3. It would be in a position to like evaluate each of these like pre-trained models, and it would be in a position to like utilize it and bring the best model at the end of the day without like thinking further much. We are kind of like investing good amount of time and effort to like, make it better so that you have the whole full automated pipeline at the end of the day with respect to the computer vision. And like, it without further ado, so you can kind of like, just select the NLP transformer, like NLP model, and it would kind of go ahead and kind of like, select either of the transformers which is best suited for this particular use case, and it would be kind of bringing the bringing the best results there. I did get a chance to complete that one. Let me. So the final, consider like, the final is like, it is having the best F1 MCC information. Even I have to like evaluate this one. So consider, let's see the insights here. So the model could straight away kind of like, pick it up with respect to the defective front, which is with the probability of like 0.998. It could kind of like, highlight with using the GradCam visualization. Why, how did it kind of end up with that particular prediction? The true class is the OK front, where it could also like, predict in the similar fashion. And the predicted again OK front, because it could kind of like see the finishes are kind of like, good with respect to it. It was a bit shiny, that is why it is kind of like, highlighting it there, I think. And the defective front, you could kind of like see the little bit of like there is a scrap or not so well finished. It could kind of like highlight it, the model could kind of like highlight it, and that is why it had saying the probability of like, one, the predicted is the defective front. So those sort of like, the straight up computer vision problem statement as well. Driverless AI would be in a position to like handle, again, like falling back to the manufacturing specific domain, where it would be in a position to like help support the inspection, like human visual inspection piece. And to give a little bit of summary here, so consider the model development. Once you kind of like load the data, run the AutoML model. That is a 21-day free trial for you to try it out, and it would be like it generates the winning model. Consider like as I said, 15 plus Kaggle grandmaster do spend their time here to give the world class like the with respect to each of the problem, either it is NLP or the computer vision, or even with respect to the time series or the usual classification problems. It generates like one of the best models out there, which you could kind of like build. And the final the Mojo model object. So through C++, Python, you can kind of like go ahead and kind of like download the predictions at the end of, like, the model itself at the end of the day. So consider, yeah, taking this as an example. So you can kind of like download it, like run the example there with respect to the Python or Java, and deploy that in your pipeline. Pretty straightforward. We have a good amount of like BA deployment templates as well in the GitHub repo for you to like utilize it. And it's one of like, with respect to the latency, it's a low latent model which you would be getting at the end of the day for you to like deploy within like a couple of hours. And definitely like as we have support for C++, Python, or even Java, you can kind of like have it in your server, which is the de facto thing. But more than the servers, like running it on the edge devices like the smartphone, or even with respect to the watch, on even with respect to the engine, where you kind of like raise an alarm with respect to that. With respect to need a little bit of predictive maintenance there, these models would always be there, where it kind of like makes a right call than the if-else statement, which is like which are there in with respect to the engine predictive maintenance piece. So like, to give a little bit of like summary here, like the data procurement, data set preparation, then the whole driverless AI would be kind of like totally helpful here. And back to the predictive maintenance, so consider like emphasizing where the air pressure systems, back to the European the truck maintenance use case, which we kind of like saw earlier, where did get a chance to get the sensor data from trucks, and driverless AI was helpful to whether the truck needs maintenance or not, and it definitely helped them to reduce the cost and look forward for better control with respect to the downtime, which they're gonna see at the end of the day. And there's a little bit of calculation here, and these are the two use cases, and definitely we kind of saw the the computer vision case as well, and we had got looking at the Petronas, or even with respect to with respect to OPEC, the Middle East, where we had got good amount of consumers there, where they kind of look at the multiple ways of utilizing it with respect to the refinery process as well for the better quality of CPU. And again, the biodiesel, that is one of the other use cases which we had got here, and the robotic welding arm. So again, this is more on the image processing, where the keyhole feature, the frequency domain. So those sort of information was kind of helpful in predicting the welding status, whether how well the finish is and such. So this is as I'm kind of I'm from the customer success team, where we do experience good amount of these use cases, and our at the end of the day, so consider having picking the right use case for the available data would be our target at the end of the day, so that kind of consider the focus is getting the best out of, squeeze the best out of driverless AI with the available data, and engage them. So I just want to emphasize what my team does, so that and we are kind of the facing the customer like you. So definitely I just want to emphasize it here. So yeah. And so I want to definitely I want to take it further with respect to each of the individual. This is a domain specific problem statement. Saurabh and I, the whole we would be there to address your questions right now, or even take it offline if that's necessary. And with respect to this particular the predictive use case, or the whole manufacturing use case, where we could leverage driverless AI AutoML platforms. Hope that gives a picture.
Thank you, Sai. That was wonderful. Let's use the rest of the time to answer audience questions. The first one asks, how do I improve quality checks in manufacturing using AI, and how reliable are the AI tools in manufacturing?
So consider with respect to the quality tools, definitely, so consider one way of kind of looking at it is the first thing is I've been there with respect to the advanced quality control discussions, where it would be with respect to the it definitely starts with the charts, right? NP charts, or the P charts, which is it kind of looks at the lower limit and upper limit kind of information, and we would be in a position to look at the distribution, how well it is away from the norm, would be our motto at the end of the day. But the very same problem which we could also pivot it towards, it would be a couple of ways. The first thing which I want to say is looking at it as the anomaly detection problem. So consider what had with respect to that particular, okay, you're kind of looking at the electrical testing, that would be 50 plus 60 plus kind of test measures, and one of them is kind of off with respect to it, but how well it is off with respect to the other testing information. So those sort of anomaly detection technique would always be helpful in evaluating this particular product, this particular the inline product, how well it is off, whether it needs a little bit of quality check with respect to that particular the one which is getting manufactured. The other way is definitely how well the same statement could be converted as a supervised learning. So the supervised learning problem and such, so how well it is getting tested. So this particular result, is that connecting back to our returns? Is that connecting back to the next stage of scrap, the failure? So those sort of the supervised learning prediction problems, I think that would also be a good technique to look at it to improve the quality at the end of the day. though. So like these NP charts, so consider you are kind of like getting too much of alarms at the end of the day, and maybe like couldn't let it been there where it wouldn't let us to like focus the problem at the right problem at the right time. So rather than relying more on these like quality control charts, AI would definitely be helpful in like having a good evaluation metric. That is where supervised learning problems would be helpful, or even like at least having an evaluation as a unsupervised learning technique for anomaly detection and such.
Thank you, Sai. How does one label data for a predictive maintenance problem?
So definitely, like as we were kind of like looking at it, which is the downtime there. Like are we kind of like looking at the downtime? That's a failure, or like running up and running kind of a clear line which we could kind of like draw. If you are kind of like having a hard time, like where we could draw the line at this data, this sand of data, definitely like we could kind of like take it offline. But definitely like if it is up and running, or like if it is down, if the machine is down, kind of a data set where you could kind of like convert that into supervised learning problem.
Great, thank you. Once a model is created using driverless AI or H2O, can I reuse that model into an AWS or GCP or any other platform for that matter?
Yes. So that is one of the like this good feature, even which I want to like emphasize here. So you can have a downloadable Java, well, Java file, .java, and a model like wheel file for the Python, where you could deploy it anywhere. As we were kind of like looking at it, even deploy it with respect to in the cars for the predictive maintenance, so that it kind of like pushes an alarm where it is not like it is offline. It is not even like connected to the internet, so that it could kind of like talk back. You are kind of like taking the whole model at the end of the day in your in your like literally speaking in your hand, and you're kind of like pushing it in any other platforms out there which you had got. So GCP, AWS, like it doesn't limit it there as well. To answer your question, even the edge devices like in phone, smartwatches, or even in your like in embedded systems where we kind of like have C++ support, you could kind of go ahead and kind of like deploy it there.
Thank you. How can we use large machine learning how can we use large machine logs for anomaly detection?
Yeah, definitely. So consider like if you're kind of like looking at the logs and looking for the anomaly detection, in H2O3 we had got isolation forest technique, like one of the models which is kind of there. That is all another like k-means clustering technique which is also kind of like there. You could kind of like definitely start looking at it and look at like what are the the anomalous like behavior which we kind of like see with respect to that particular logs, without looking at it as a supervised learning problem. So definitely like even autoencoder is all again available with H2O3 open source platform, and we kind of like have it in the driverless AI as well. Actually, like one of our Korean customer are kind of like using driverless AI with for the same like the log analysis. A similar problem which we are kind of like facing, we are using driverless AI and kind of like like having the deployment perspective through isolation forest technique. So and even with respect to the isolation forest technique is available via recipes in driverless AI as well as in the open source. So look into the isolation forest. If not, like if you're kind of like having trouble, like we can take it offline for sure, because we would be there to help you out.
Thank you, Sai. The next question asks, can predictive simulation be combined with machine learning for predictive maintenance?
Predictive simulation, like what would be okay? I mean, like consider you're kind of like using the simulation for augmenting the data. That would be my take. With that notion, definitely yes. So consider you're kind of like increasing Or maybe not. It depends on how we gonna like. Maybe a little bit of context would be helpful in this question. Yeah,
Sure.
if
So
yeah,
the
if we can kind of
attendee
get
who
back
asked this
to.
question,
Yes, yes. Please, it would be great if you could elaborate more. Like, what do you mean by predictive simulations? If we could kind of like answer it at the end for sure.
absolutely. Thank you, Sai. The next one, do you have an option to build optimization based on prediction models or predictive models, let's say? Or how do you optimize the models?
Yeah. So okay, so let's take cost as a factor. Though consider the downtime with respect to this particular, we could okay maybe like a little bit of like getting back. We can have a custom loss metric for us to like use it in the driverless AI, which utilizes like a different. So consider the model. It kind of like considers the weightage for the classification misclassification of the non-failure versus a failure is kind of equivalent, but you can add a cost metric at the end of the day to that particular model and kind of like ask the driverless AI kind of like supervised learning platform where you could kind of like optimize in that particular fashion. So that is one way of kind of like addressing it, or definitely like having where we had kind of like seen rather than like looking at the cost metric where it was kind of like hard for the business user to evaluate. We have like multiple three different. Let's take um, predictive maintenance of the machine one versus predictive maintenance of line one versus the predictive maintenance of line two, whereas line two kind of like costs us more. So we could kind of like have two particular models which is kind of like getting trained on those two particular lines, and we can at the end of the day use a cost metric on top of it to optimize whether like should our service managers should they attack line one right now or line two right now, because the line two cost is kind of like more kind of where we could nudge the results in that way coming out of driverless AI. Even if not, you can kind of add more weightages to the line two failures than the line one failures. Thereby the model always kind of like takes care of it. So more or less, I mean, like it's you how do you kind of like want to like play with it would be the question. So definitely yes, optimization through supervised learning problem, at least on most of the cases it is feasible. But if not, you're kind of like having a constraint like linear programming kind of problem where you're kind of like looking at scheduling, then where guinea pigging my experience in industrial engineering there, definitely like then with respect to that case, definitely like supervised learning wouldn't be a case. But you can answer questions, some of the questions like by segregating it would be my answer. Depends on overall, in generically speaking. But if it is a whole scheduling problem where you're kind of like using it for alerting the crew member for your airlines kind of problem, where, or even like alerting engineers or workers for those particular lines, then definitely like supervised learning problem wouldn't be the technique. But if it is with respect to the line one and line two, where we have to like address it to an extent, yeah, driverless AI kind of like it would be better to look at it as a supervised learning problem, because you have a more control having evaluation metric in your hand. You can evaluate the model at the end of the day.
Great, thank you, Sai. Next question, can we develop an incremental learning system based on the continuous input data for prediction?
More of an active learning piece, yeah. And to an extent, it is available in driverless AI. So you can kind of like train with the last checkpoint, where the continuous like the data where you could kind of like integrate, train the model there, which is feasible. If you're kind of like looking at it as a online machine learning, where you're kind of like looking for the trends and such, maybe like you need smaller like packets of model there. It is kind of like feasible to an extent from driverless AI perspective for sure, yes. But again, like it would be great to like delve into the problem statement which you had got.
Great. Is it possible to use H2O library in R and run the model and download the model for Java and or Python development?
Yes. So H2O3, I mean, like this is a fun, like in a good old history. Was just, initially it was more with R than Python. So like back in the days. So and okay, you can kind of like build a model. There is a H2O flow which you kind of like have a user interface. Kind of it opens up in your computer with the port 54321, and once you kind of like initialize it through Python or it doesn't matter. There is always one Java instance where it kind of like talks to Python and R, so you can kind of like import it across for sure. And you can have a downloadable Java file at the end of the day in H2O3 platform.
Great. Can we compare the top most accurate models based on evaluation metrics from driverless AI?
Yes. So there is a project space. I hope I'll kind of like quickly showcase that to you. You can, even while starting the model as well. 1 minute. While initializing the model as well as after even evaluating the model, there is a diagnostics and as well as like the project space which kind of like helps you to do that while starting the model. So for example, let's take the same image classification as an example, which is having like defective okay and defective front and the okay front. You have already like with respect to the classification, you have good amount of evaluation metric to optimize for the iteration to like evaluate and optimize. So it's pretty much there. You even more than that, you can bring in your own custom recipe for you to evaluate. That's pretty much there. And definitely like look into the recipe. Just search for recipes in driverless AI. There are good amount of examples which are kind of available there where you can kind of like upload it from here, and there is an official like recipe with respect to that. Even consider one of the recipe which we had got as like in a video to image. Babakin on another Haggle grandmaster, so he is kind of like leading the effort in image, so he had kind of like pushed that particular recipe there. So definitely this is an open source like driverless AI recipe such to that's the link. So it's worth checking it out with respect to that. Yeah, I answered the question.
Can we also supply our own custom models into the pipeline to compare with these models?
Yes. So custom models, custom data. If there is a data recipe as well, which you want to like include that into your final model. Custom scorer, custom recipe, and yeah, custom model. Like 4 things. I hope I'm repeating myself, but yeah, you got the picture. Yes.
Thank you. Let's get one last question. Can we use transfer learning for predictive maintenance?
Transfer learning for predictive maintenance. Definitely yes. So we had seen like I'm more into the transfer learning piece for sure, where did spend a good amount of time. But again, with respect to that particular question, like how do you match? There should be a common decorum. So consider classification of dogs and cats with husky versus wolf. You kind of like have a little bit of feature there to like explore. Whereas with respect to this particular one, at least there should be a little bit of common decorum for it for the models to like kind of utilize, than rather than like trying to classify dogs versus cat with the predictive maintenance. It doesn't help you a lot. So transfer learning definitely, that should be a notion would be the take. But definitely, so consider even with respect to, we had seen in the tabular data, transfer learning is helpful in some of the use cases which we had seen. So definitely a good to go kind of like recommendation which I've got. But with a little bit of star at the top saying like, what are you gonna do, like what is the context would be my question, the next question. Yeah.
Okay, great. I think with that, we're at the top of the hour and would stop. Thank you to our audience for staying, asking wonderful questions. Thank you, Sai, for giving a wonderful presentation, taking the audience questions. Have a great rest of your day, everybody. Bye.
Thanks, Sairaam, and thanks, people. Yeah, bye. Talk to you soon.